Good evening to all. Myself Thota.Akhilasri. Today my seminar topic is finite state mission. The definition of a finite state mission. A finite state mission, it is simply called as FSM. It is a mathematical model of computation used to design both the computer programs and sequential logic circuits. It consists of a finite number of states and the system transitions from one state to another based states on inputs. In simply, we can call as an FSM is a system that can be in only one state at a time and it changes states when certain conditions or inputs occurs. FSMs are widely used in digital circuits, compilers, control systems, communication protocols, etc. And we have discussed the key points of finite state mission. Key components of an FSM. An FSM has five main components. Number one, states. These are the various conditions or models in which the mission can exist. For example, ideal or processing done. Number two, input symbols. These are the external inputs or signals that cause the FSM to change from one state to another state. For example, button press or clock pulse or 0 by 1 signals. Number 3. Output symbols. Outputs generated based on the current state or the state and the input. In FSM, have different types of missions, that is More mission and Melee mission. Later we have to discuss about that. And these two missions are undergo with the key component of output symbols. That means More mission output depends only on state. Melee mission output depends on state plus input. And number 4, transition function. This defines how the mission moves from one state to another. It is written as del of current state and input, that means next state. For example, del of ideal comma 1, that is processing. Number 5, initial state. This state in which the FSM starts operating. Number 6, it is an optional key component of finite state mission, that is sixth one, final or accepting state. Special states that indicate successful processing. Mostly it is used in automata theory and processors. And now we have discussed about the types of finite state mission. Types of finite state missions. Finite state missions are mainly classified into two types. Number one, More mission, and number two, Melee mission. Firstly, we have to discuss about the More mission. A More mission is an FSM, that means finite state mission, where the output depends only on the current state, not on the input. And the characteristics of More mission, that is output changes only when the state changes. Generally simplifier to design, more stable output, less affected by the input changes. The output function of the finite state mission is output equals to f of state. And Melee mission. A melee mission is an FSM, that means finite state mission, where the output depends on the current state and the current input state. The characteristics of melee mission. Output can change immediately with input. Usually needs fewer states than a Moore mission. Faster response to inputs, and the output function of melee mission means output equals to f of state plus input. So now discussed about the next one. That means similarly we have differences between the More mission to Melee mission. In this PHS, the output depends on state in More mission. The output depends on state plus input in Melee mission. In More mission, the output changes on state change. In Melee mission, immediately on input change. In More mission, the number of states are more compared to Melee mission. In Melee mission, the number of states fewer compared to More mission. In More mission, the design complexity is simple. in Melee mission, the design complexity is slightly complex compared to Melee mission. And response speed. The Melee mission response speed is slower than compared to Melee mission. In Melee mission, the response speed is faster compared to Melee mission. We have to discuss the other variants of FSMs. Less common but useful. Although Melee and Murray are the main types, there are some extended types. Number 3, deterministic FSM. It is simply called as in shortly DFSM, that means deterministic finite state missions. For a given input and state, only one next state can exist. It is used in commonly digital circuits and compilers. Fourth one, non-deterministic FSM. That in simply we have to call NFSM or NFA. For a given input and state, multiple next states may exist, mostly used in automata theory. Fifth one, synchronous FSM. That means state transitions occurs on a clock signal. And sixth one, asynchronous FSM. State transitions occurs whenever output changes. That means no clock pulse. And now we have to discuss the limitations of finite state mission. Limitations of finite state missions. Finite state missions are powerful for sequential logic designs, but they also have several limitations. First one, cannot handle large memory or complex tasks. That means FSMs have no memory except the current state. They cannot store large amounts of data or remember long history. Number 2, number of states grows rapidly, state of exploration problem. For example, systems, the number of state increases exponentially. This makes the FSM harder to design, draw and implement. Number 3, cannot handle recursive or context dependent inputs. That means FSMs cannot process inputs that require memory of previous inputs beyond the current state. And next one, fourth one, difficulty to modify once designed, changing the behavior of an FSM. That means adding new cases or transitions often requires redesigning many parts of the mission. Fifth one, cannot handle parallel or concurrent events easily. FSMs process one input at a time, so they cannot manage multiple simulations events unless the design becomes much more complicated. And sixth one, sometimes slowly for real time systems. If many systems need to be checked or transitions are complex, the system may not respond fast enough. And seventh one, limited scalability. Finite state missions work well for small and medium systems but become inefficient for network protocols, complex protocols, controllers, large embedded systems. And we have to discuss the capabilities of finite state mission. Capabilities of finite state missions. Finite state missions are powerful tools in digital logic and computation. Their major capabilities are: number 1, can model sequential logic systems. That means finite state missions can represent systems where the output depends on the current state and past inputs. For examples, traffic lights, vending machines, washing machine controller. And next one, can recognize regular languages. FSMs can accept or reject input strings that belong to regular languages, which are defined by regular expressions. For examples, recognizing binary strings with an even number of ones, detecting specific patterns in input streams. Number 3, can perform control operations. FSMs are ideal for systems requiring step by step control, such as microprocessor control units, protocol controllers, robot movement controllers. Number 4, can implement simple counting. Finite state machines can count up to a limited range by creating different states for each count value. For example, a three state counter can count 0 to 1, 1 to 2, 2 to 0. Useful in compiler design and pattern machining. FSMs are used in lexical analysis, token recognition, pattern searching. In, for example, KMP algorithm. And last eighth one, easy hardware realizing. FSMs can be implemented using flip-flops, combinational circuits, thus they are widely used in digital circuit designs. And now we have to discuss the applications of finite state machines. The finite state machines are used in our daily applications like number 1 digital circuit design, number 2 control systems, that means washing machine or elevator, number 3 communication protocols, number 4 compiler lexical analysis, number 5 robotics and automation, number 6 game development, number 7 pattern recognition, number 8 vending machine, number 9 embedded system controls. These are all the daily applications in our daily life of finite state machines. And now this is all about the detailed explanation of finite state machines. And thank you. Thank thank you.